Continuing on with the vocab, we're going to look at an arc. And an arc is part of a circumference. So if you were to just sketch in part of that, that would be an arc. So part of the circumference. And what we're going to be able to do is also find the arc length. And all you do that is you take the circumference, so the arc length is equal to the circumference times the fraction, the arc angle, divided by 360. So for example, if your arc angle was 180 degrees, you had a half a circle, 180 divided by 360 would be 1/2. So you multiply the circumference by 1/2. Or if you had a fourth of a circle, 90 degrees, 90 divided by 360 is 1/4. 1/4 times c would be a fourth of whatever your circumference is. So that's why you take c times your arc angle divided by 360. Getting more specific, a minor arc is an arc less than 180 degrees. And whenever you have an arc less than 180 degrees, you can give it a two-letter name. So let's say the endpoints of this arc are A, B. So we often have little points on the circle on the edge. So we know that the endpoints of this arc are A and B. So we would call this arc AB. And you put a little arc symbol over it, kind of like you would with a line segment. You put a line. Since it's a curved line, you put a curved line above it. Now a major arc, on the other hand, similar idea, but now we're talking about a much longer distance. So let's actually clarify that by going the other direction. So we'll give it the same endpoints, A and B, just like we had before. But this time, we're going to throw in an extra point over here because we're going the other way. A major arc is an arc more than 180 degrees. And so an arc that is more than 180 degrees needs a three-letter name to clarify that it is not the shortest path. AB, if you just called it arc AB again, we would think that we're talking about that green thing there, the shortest path. But we're not. We're actually talking about the longer path. So you would call it arc ACB. Three-letter name. Kind of like you would do with angles, you just follow it along the path. Same thing here, you follow the arc along the path. You go from A through C all the way and stopping at B. It could be any point. If there are multiple points along A and B here, you could use any one of those points, but you only pick one. You don't need a four-letter name. A three-letter name is enough. A semicircle is just half of a circle. Simple as that, half of a circle. So a semicircle is going to have an arc length that is half the circumference. It's going to have an area that is half the area of a full circle. A sector is where you draw a radius and then you draw another radius. You draw a radius and then you draw another radius. And that whole region that you just filled in here is called a sector. Now when you're finding the area of a sector, it's kind of like the way that you would do arc length. So the arc length is just talking about the outside edge. The sector is focusing more on the area. So the area of the sector is going to equal the area of the circle times the arc length divided by 360. All it's saying is what fraction of the circle do you have? If this is a 45-degree sector here, 45 over 360 is 1/8. that means that you have 1/8 of the circle. So your area is going to be 1/8 times the area of the entire circle. So that's all you're doing with sectors. You're saying, what fraction do I have? And it's how many degrees out of 360 that forms that fraction. Scrolling down here, we have central angle. A central angle is any angle that is measured from the center of the circle. So we're going to clarify that this here is the center. It is an angle measured from the center of the circle. Central angle, angle measured from the center. Next one, concentric circles. Con means with, centric means center, so it is with the same center. So a concentric circle would be a circle like this inside of the other circle. Both of these circles share the same center, so they are concentric. Circles that share the same center. Down near the bottom we have inscribed and circumscribed figures. An inscribed figure is a figure that is inside the circle. It is inside the circle. A circumscribed figure is a figure that is outside the circle. Now let's go clarify a few things about both of these. So with the inscribed figure, every point touches the edge of the circle. So every corner of the polygon touches edge of circle. Whereas a circumscribed figure, circum meaning outside, scribed meaning drawn, so drawn outside the circle, every side is tangent to the circle. So every side, somewhere in the middle of the side, not necessarily the exact center of the side, but somewhere along the side, there is a point tangent. So every side is tangent to the circle.